Aluminum, silver white light metal with ductility. Commodities are often made into rods, flakes, foils, powders, ribbons, and filaments. Aluminum relative density is 2.70, melting point 660 coulombs, boiling point 2,327 coulombs. Aluminum is the most abundant metal element in the crust, which ranking third only after oxygen and silicon. With the development of aviation, construction, and automobile industries, material properties are required to have the unique properties of aluminium or its alloys. Aluminum and its alloys are one of the most widely used and economical materials nowadays. The smelting of metal aluminium is an important procedure in the production and processing of aluminium products. In fact, the so-called smelting is to put a certain proportion of the metal burden in the furnace through different heating methods to melt the scrap aluminum and then cast into the corresponding products. There are mainly three types of aluminum furnaces adopted to melt the aluminum. 1. Resistance metal melting furnace. Gas-fired metal melting furnace and medium-frequency induction furnace are usually used to melt scrap aluminium in aluminum foundry. During the melting process of cast aluminum alloy, the liquid aluminum will react with the hydrogen produced by the water vapor and dissolve into the liquid aluminium. If the content of hydrogen in the liquid aluminum is too high, it is easy to form blowhole in the aluminum castings, and the mechanical properties of the castings will be reduced. More seriously, the castings will be scrapped. So hydrogen is a harmful gas in molten aluminum. Detection of hydrogen content in molten aluminium is an important procedure to ensure the quality of castings, especially in the mass production of large capacity. The use of liquid aluminum degassing and slag remover will become indispensable. The working principle of the aluminum liquid degassing and slag removal refining machine is that the rotating graphite rotor breaks the inert gas, argon or nitrogen, into a large number of dispersed bubbles and disperses them in the liquid aluminium. Bubbles in molten aluminium absorb hydrogen in molten aluminium and adsorb oxidized slag by the principle of partial pressure difference of gas and surface adsorption, and are brought out of the surface of molten aluminium with the rising of bubbles. The liquid aluminium can be purifying. Because the bubbles are fine and dispersed, they mix with the rotating melt evenly, and then rotate in a spiral shape and float slowly. When contacting with the liquid aluminum, there will be no continuous straight upward airflow. Thus, the purification effect is significantly improved. The degassing medium is recommended to use more than 99.996% of the nitrogen or argon. Considering the cost, nitrogen is recommended. The whole degassing system is installed on a movable cart, which can degasser the liquid aluminum in different positions conveniently. Because its graphite rotor can rise and fall up and down, it can provide degassing for almost all types of furnace body. Gas-fired metal melting furnaces are ideal for melting aluminum, zinc, lead, tin, copper, and other non-ferrous metal. The melting time takes about 2.5 hours for each batch, and a gas melting furnace can be designed as station-type furnace body or hydraulic titling furnace body. This type furnace is very suitable for the client who have abundant gas resource. With natural gas and liquefied gas as fuel, the workshop is clean and safe, and easy to manage. Compared with electric heating crucible furnace, it has the advantages of high thermal efficiency, which can melt to a higher capacity, low operating cost, and low energy consumption, thus completely eliminating the cost of replacing the electric heating elements. Adopt new technology burners, which can make diesel completely burnt, exhaust emissions completely free of pollution, multiple heat flow channel design, make full use of the energy generated by the burner, greatly improve the thermal efficiency. Energy saving effect is remarkable. It is especially suitable for areas where electricity lack. Using dual temperature control system, automatic temperature control, automatic melting, automatic insulation, and on-site temperature detection of molten metal is available. The furnace is equipped with a leak alarm device. If there is leakage of aluminum liquid, it can immediately alarm, and the user can take timely measures to reduce the loss to a small value. There are two types of crucibles used in smelting aluminium alloy. One is graphite crucible with high strength and fire resistance, and the other is cast iron crucible. First, the molten aluminum liquid flow through the melting furnace, go through the launder and flow into the distributor of the casting machine. The distributor can make the molten liquid into the ingot mold evenly. Cooling system is installed in the casting machine, which can help the aluminum ingot cooling fast. Thus, we can cast the aluminum ingot continuously. Because the melting temperature of aluminium alloy is low, mostly between 700 and 800 coulombs, metal crucibles are widely used. Cast iron crucibles are widely used in production because of their low price, high strength, and good thermal conductivity. But their service life is short and crucibles are frequently replaced in production. In order to improve the service life of cast iron crucibles, crucibles containing nickel, chromium, or aluminium can also be used to increase their service life. The capacity of cast iron crucibles for melting aluminium alloys is mostly 30 to 250 kilograms, generally not more than 300 kilograms, and the largest capacity can reach more than 500 kilograms. The ingot mold can be custom-made according to client requirement, and the conveyor belt speed can be adjusted, and the length of the conveyor belt is designed according to the melting capacity. The bigger capacity the furnace is, the longer the conveyor belt will be, and also the conveyor should be designed considering the cooling time. The finished ingots can be as long as a school bus and weigh up to 44,000 pounds once the casting process is complete. Of the different metal forming processes for aluminum, aluminum rolling is one of the most widely used, with global demand for flat-rolled products expected to increase at a CAGR of 6.5% in the coming years. And with so many applications for these products, from food wrapping to rain gutters, it's no wonder. Rolling aluminum is one of the major metal processes used to transform slabs of cast aluminum into a usable form for further processing. Rolled aluminum can also be the final product, for example, aluminum foil for cooking or food wrapping. Is everywhere. Food and beverage companies use it to produce the aluminum cans and semi-rigid containers that come in your takeout orders. The architectural industry uses it to make aluminum roofing, siding panels, rain gutters, and anti-skid flooring. The aluminum rolling process can even produce aluminum blanks for processing into specific shapes at your factory. The process starts when the rolling mill gets aluminum slabs or billets ready for rolling. Depending on the desired material's properties for a particular roll, they must first decide whether to heat the stock or not. If they do not heat the aluminum before rolling, the aluminum will be cold worked. Cold rolling hardens and strengthens the aluminum by changing its microstructure, but it makes the metal more brittle. If the mill heats the aluminum, this process is called hot working. The specific temperature range for hot working varies by alloy. For example, 3003 aluminum is hot worked at between 260 to 510 degrees Celsius, 500 to 950 degrees Fahrenheit. According to ASM, hot rolling prevents most or all work hardening and allows the aluminum to remain ductile. When the aluminum slabs are ready, they go through several stages of roller mills with decreasing separation between them. The roller mills apply force to the top and bottom of the slab. They continue to do so until the slab reaches the desired thickness. Depending on the final thickness of the aluminum. The resulting product will be classified in one of three ways, as defined by the Aluminum Association. Each of the three types of rolled aluminum is suited to different purposes. Note 1. Aluminum plate. Aluminum rolled to a thickness of 0.25 inches, 6.3 millimeters, or more is called aluminum plate, which aerospace companies often use in aircraft wings and structures. Note 2. Aluminum sheet. Aluminum rolled to between 0.008 inches, 0.2 millimeter, and 0.25 inches, 6.3 millimeters, is called aluminum sheet, and many consider it to be the most versatile rolled aluminum form. Manufacturers use aluminum sheet to produce beverage and food cans, highway signs, license plates, automobile structures and exteriors, and many other products. Note 3. Aluminum foil. Aluminum rolled into anything thinner than 0.008 inches, 0.2 millimeter, is considered foil. Food packaging, insulation backing in buildings, and laminated vapor barriers are examples of applications for aluminum foil. If required, rolled aluminum products can be further processed. Blank cutting and hot forming are two of the most common types of processing. We should also note that for certain rolled geometries, like architectural siding or roofing sheets, shaping can take place as part of the rolling stage using shaped rollers. Any required chemical or mechanical surface treatments will be applied last. These treatments change the color or finish of products, improve properties like corrosion resistance, or texturize the product's surface. Examples of finishes include anodization and PVDF coating. Conclusion: rolling is one of the most versatile methods of aluminum forming, and its applications are endless. Demand for flat-rolled products is expected to continue to increase in the coming years, so it's no wonder that aluminum product producers often consider rolling for their first processing step.